start the hypothesis testing too by looking at errors in hypothesis testing. We have two types of error. Type 1 is rejecting the new hypothesis when it is true. So it's true, but we're rejecting it. So this is one error, right? Another type of error is we accept the new hypothesis when the new hypothesis is actually false. So we thought that it's true, but it's not true. So this is type 2 error. Okay, it is summarized in this metric. It's called confusion metric. Okay, so this is correct decision. We reject the new hypothesis when S0 is false. So this is correct. We accept the new hypothesis when this is true. So this is also correct. Two types of errors in here and here. Alright, so alpha is the percent of type 1 error and beta is percent of type 2 error. Okay, we're gonna skip this example for now. Go to the next one. Okay, this is example error types. Okay, let's see. If the average body temperature of normal people is equal to 37 degrees Celsius with the standard deviation equal to 0.4, and the body temperature of people with fever range from 38 to 41, this is with 95% confidence level. Okay, so 38 to 41 is 95% confidence interval, and the security guard was told that people with temperature greater than or equal to 37.5 are considered having fever. Okay, so the new hypothesis is mu equal to 37, and we can conclude that that person doesn't have fever, and the alternative hypothesis is mu is greater than 37 and the person has fever. At example error types here. So the average body temperature of normal people is equal to 37 degrees Celsius with standard deviation equal to 0.4. The body temperature of people with fever ranged from 38 to 41. This is 95% confidence, so the 38 to 41 is confidence interval of the people with fever with 95% confidence. And the security guard was told that people with temperature greater than or equal to 38 Celsius are considered to have fever. Okay, so the new hypothesis is mu equals to 38. Oops, no, not 38, 37. Okay, you shouldn't be confused, right? So mu is 37, people doesn't have fever, and mu greater than 37, people has fever. 38 degrees Celsius is actually the critical value. So we have critical value critical value is here, 38. Okay. So what is error type 1? Oh, so this is distribution of normal people temp. This is fever temp. Okay. So the error type 1 is this one, right? Because this is critical value. So this is error type 1. Error type 2 is it's gonna be this area. This is error type 2. So this is beta. And now we want to calculate so okay, alpha is the chance that the probability that we will reject the null hypothesis, right? Because our null hypothesis is people will have temperature equal to 37 degrees. Okay, so with this critical value, we're gonna reject the null hypothesis when the measured temperature is greater than 38 degrees Celsius. Okay, and the beta is what? Beta is when people who actually have fever but got accepted, but the temperature is lower than 38 degrees. So this is the probability that people with fever will have the temperature lower than 38 degrees. So the security guard will think that, okay, he is fine, but actually he is not fine, he has fever. Okay, so the probability of beta is here. Alright, so let's go to the Excel. Try to calculate value of alpha and beta. Okay, what is the value of alpha? Alpha is gonna be what? Norm, right? Dot dist, and x is 38, right? And the mean is what? 37. The standard deviation is 0.4. Cumulative, yes. And this is gonna give us this number, this value. Okay, so this is gonna give us this area here up to this point, right? So it's almost 1, but what we want to find is the area here at this point. Okay, so alpha is 1 is equal to 1 minus this, so it's about 0.006. What about beta? Okay, beta is gonna be norm dot east. And 38. Mean is 39.5. The standard deviation is what? Oh, we still don't know the standard deviation, right? But from here, we can estimate that the standard deviation is about 0.05, right? And the cumulative is true. So the probability of error type 2 is about 2%, 2.3%. Okay, which is this one. This is the proof that S is around 0.75. Okay, we know that 39.5 here minus 39.5 here minus 38. This is around 1.96, right? Okay, so so we do the calculation here and we get S equal to 0.765. The distribution of body temperature, both of these are normally distributed.